Hello, good evening, everyone. So we'll start the discussion for N-term mode. So what was your question number one? Let me just share the screen for the question. Okay. So first question is, consider 100 samples that are independent and identically distributed normally with mean nu and variance 1. Let the null and alternative hypothesis be nu is equal to 0 and the null alternative is nu greater than 0. Suppose the test statistic t is equal to x bar. Consider the test that reject null if t is greater than c for some constant c. What will be the type 1 error? So have you guys done this question? So
Yes,
how to
ma'am.
work with that? Let's discuss that. So we have null hypothesis there that says h naught is it says mean is 0, and another one the alternative hypothesis says it is greater than 0. Fine. And taste is also defined as we discussed. If xi's are x1 to x100 are there, they are IID normally distributed, and its mean is nu and variance is 1. Which taste will you guys would like to use there? T is x bar, it is given again. And even the taste is also given that reject h naught when t is greater than c, right? So what would you like to do there? Yeah. Which taste will be applicable here to find the yeah type 1 error? So probability of type 1 error is what?
Reject
Alpha, ma'am.
null.
Yeah, type 1 error, that is nothing but probability of rejecting null when it was true, right? When it is true. So here in this case, this rejecting null is nothing but t greater than c, and when mean is equal to 0. Fine. So yeah, just go with it. So which test will be applicable here?
Z test.
Z test. Why it is so?
Because we have checking for the
Mean is known.
and variance is known.
That is not the reason. Yeah, what should it be? This means we are taking 0, but why Z test? You are selecting Z test. You can select T test also. The reason is sigma is known to us. Variance
Yes,
is
ma'am.
known to us, so we'll go for the Z test. If variance was unknown, we will go for
T test.
T test. Yeah. So yeah, this is 1 upon C upon 1 upon square root of 100. So this one is nothing but the Z distribution, right? This is Z distribution, or you can say it as a normal distribution, which is following with mean 0, variance 1, right? That is probability of Z greater than C upon 1 by 10. So once we solve it,
One
we know the
one
PDF.
minus fz of 10c.
Yeah, fz of 10c. So that is what asked to us, right? What is the
Yes, ma'am.
probability of type 1 error? That's it. So let's move to the next question. What is probability of type 2 error? When alternative hypothesis says that mean is equal to 1. So how to proceed with that? What is type 2 error?
Except it's not given H is true.
Except H naught. Okay.
H naught,
Okay. Fine.
except null when alternative is true.
Yeah. Type 2 error. Accepting null when when H HA was, or your H1 is true, right? Okay. So here, what does it mean by HA is true or alternative hypothesis is true? Or what do you mean by accepting H naught?
T is less than C.
Okay. How did you decided this T less than C?
Because we reject when t is greater than c.
Yeah, exactly. See, we have set our test as reject H naught when T less than C. So when will we accept when T is less than C, less or equal to C? You can say both ways. Okay. So given that alternative is true. So what does it mean by alternative is true in this particular question? The mean
Equal
has
to
to be
1.
equal to 1. So, okay. So we have T sample mean, right? And they are normal distributed with some mean and variance 1. So we'll try to convert it in a normal form. So how can we do that? T minus subtract from the mean and divide it by standard variance, right? So that's it. Once we put all this value, we will get type 2 error. So yeah, after putting all this value, we know that this left hand side, that means this random variable t minus 1 upon what is sigma is 1, and square root n, that means square root 100, going to be 1, right? Sorry, 10, will follow z distribution. Once we know that any random variable is going to follow any particular distribution, we will go to find what's its CDF and we'll get our solution. So yeah, this particular part is going to follow Z distribution, normal distribution, which means 0, variance 1. So Z is less than C minus 1 upon 1 by 10. Okay, less or equal to is fine, because accepting null at t greater than 0, that means, sorry, rejecting it at t greater than C, that means we will accept it at t less or equal to C, right? So this is nothing but again CDF of Z at a point 10 times C minus 1. So this is what probability of type 2 error. Okay. So any doubt till now?
If they have asked for the power, then it will be 1 minus, no?
1 minus, yeah.
Okay.
So the next question is, let X be uniformly distributed over the interval minus a to a, for what value of a probability of X will be less than 1 by 2. It is given that probability X less than 1 by 2 is 0.7. Okay. So how to proceed with this kind of stuff when random variable, its distribution is given at some particular point, its
We
CDF
can
is
use
also
the
given.
formula for the CDF of uniform, x minus a upon b minus a.
Yeah, that will be helpful here. So it is given that X is following uniform distribution over the interval minus a2 plus a, right? And it is also given that probability X less than 1 by 2 is 0.7. So we know that probability X less than some point is nothing but CDF of a given distribution, right?
Yes, ma'am.
If X is a distribution, and then f of X will be probability of random variable taking all the values less or equal to small x. So I can write it as f of 1 by 2, where my X is following uniform distribution. So once you know that X is following uniform distribution, what will be your CDF?
x minus half upon 2a.
Uniform distribution, let's say a comma b. In that case, our f of x or CDF is nothing but x minus a upon b minus
b
a, right?
minus a.
B minus a. Fine. So what is a in our case? It is minus a, right? And
Yes,
b
ma'am.
is a and x is 1 by 2. So just put all this value here. So we'll get 1 by 2 minus of a upon b is a minus of a, which is equal to 0.7. Now equation and one unknown variable, obviously we can solve it, right? So 1 by 2 plus a upon twice a is equal to 0.7. Now, yeah, just solve it. What value you are getting there? Plus a, which is 0.7 times twice a. So 1 by 2 is equal to, this will be 1.48 minus this a. Okay, so this is nothing but 1 by 2, 0.4 times a. Okay, so a is equal to 1 by 2 times 0.4. So that is nothing but 1 upon 0.8. So once we calculate 1 upon 0.8, what will you get? 1.25? Is it?
Yes, ma'am.
Okay, so that was all.
Ma'am,
Yeah.
one more thing.
Yes.
We can find the PDF and integrate in the range -a to 1 by 2 and equate it to 0.7.
Yeah. That is also the CDF only. When you integrate it,
Ma'am,
like,
can you do that way once?
yeah, what?
Ma'am, can you do that way?
Yeah. So probability that x is less than 1 by 2 is nothing but what? Integrating it from the minus a to 1 by 2. Why I have taken lower limit as minus a?
This is support, ma'am.
That is support. Minus 8. See, x is uniformly distributed from minus a to a. Right? Now just tell me what will be the PDF of this distribution?
1 upon 2b, 2a.
1 by 2.
1 by 2. Why it is 1 by 2?
1 by 2a.
1 by 2a.
Yeah. 1 upon b minus a is the PDF for a uniform distribution, right? 1 upon b minus a. So once we take a minus of a, it's a twice a. Okay. So PDF of it, let's say f of x dx, right? And now just integrate it. Minus a to 1 by 2 and this is equal to 1 by 2a. So it's a constant. So by twice a, and this will be 1 by 2 minus of a. Is it fine? Like, it's a
Yes,
1
ma'am.
by 2a constant and integration will be x minus a to 1 by 2. Okay, this probability is given to us, that is 0.7, right? And 1 by twice a, for here it will be 1 plus twice a upon 2. All right, now solve it. What are you getting there? 1 plus twice a, and here it is 0.7 times 4a.
Ma'am, if there is given greater than sign, then we will minus 1, no?
What?
1 minus.
Yeah, in that
If
case,
it,
we will go for the 1
yes,
minus.
ma'am.
Yeah. So it is what it is 2.8 a minus twice a, which is equal to 1. Okay, it's again a, sorry, 0.8 a is equal to 1, 1 upon 0.8, right? That's what we got from earlier also, that is 1.25. Okay. So that was through integration. Yeah, what were you asking? If it was probability x greater than 1 by 2, then
Yes,
what
ma'am.
we'll do? will
1
uh,
minus
sub-
probability of x less than equal to half.
yeah, that's we have to use CD whenever the distribution is given to us, there are two ways to calculate anything. Either you go by the integration or by using this, that is CDF. You can do this from one more thing, that is integration. So just tell me what will be the integration limit in that case
1 by 2 to a.
of x dx. Yeah, 1 by 2 to a. So both are the ways, whatever is suitable for you, you can go with that. Okay. Okay, any doubt till now? Okay, no, then let's move to next question. So fourth one, it says, let the random variable x and y each have the range 1 and 2. The following formula gives the joint PMF for probability x is taking value I and y is taking value j is given as I plus j by k, where k is unknown. Find the probability, okay, x is lying between 1 and 2, y is lying between greater than 1 but less than 2, less or equal to 2. So, okay, how to do this kind of questions?
First, we
Ma'am,
will find the table.
Okay,
then find k and in that range you can go.
okay. So, it is given that x and y are following. They can take these values. So, just can you just tell me which kind of random variable these are?
Discrete random variable.
Okay, discrete random variables that are taking only two values. Okay. And one more information is given to us is x is taking value I and y is taking value j. This probability is given by I plus j by k. Okay, so can we have table from this joint?
Yes, ma'am,
Table?
we can do.
Yeah, and the question is probability that x is lying between 1 to 2 and y is y less or equal to 2. Is question mark. So which values it will take?
1 1.
Equal to 1,
Sorry.
comma,
1
y
2.
equal to 2 plus
FY
probability
of
of
2.
x equal to 2, comma, y equal to 2.
FY of 2.
Okay. So can I say like x is lying between 1 and 2 and x can take only two values, 1 and 2. So probability
Yes,
that
ma'am.
x is taking 1, probability x is taking 2. And what about y?
Only
Find
two.
only
Y
Only
can take
two.
only two value 2, not 1, right? So
Only one.
only one value, that is y is equal
Yes,
to
ma'am.
2. That's it, right? We want to add this probability. That will give us the required part. Right. So what do you think? What is the value of x there? Sorry, k there.
That is 12, ma'am.
Okay. So here we can use I plus j by k, right? The probability formula was I plus j by k. What is I1? J is 2, right? So it is
3 by
3
k.
by k plus this one is
4 by
4 by
k.
k. So 7
7
by
by k.
k is unknown. Now, okay. So probability like x can take either 1 or 2 and y can take values 1 and 2, right? Both x and y belongs to 1, 2. So in the table, if I form, that will be easier to understand, right? So let's make a table first. Let's say these are the x values, these are the y values. Then 1 and 2. There are also 1 and 2. So, okay, what is the probability here? 1, 1. So, I plus j by k. So, 2 by k. Again, this will be 3 by k, 3 by k, and 4 by k. So, how to get the value of k then?
total
Add and equate
probability.
it to 1, ma'am. Add
Yeah,
it
we
and
know
equate to
that
1.
the all the probabilities should sum up to 1. So that will be 2 by k plus 3 by k plus again 3 by k plus 4 by k. That will be equal to 1. So it is 3 plus 3, 6 plus 2, 8 and 12. Okay. So 12 by k is 1. So k is equal to 1 by 12. Okay. Why I can say this, all these things are correct? Because we know that
Equal to 12, ma'am.
summation of, yeah,
Or total probability.
should be equal to 1. Yeah, what someone was asking some question or anything.
K equal to 12 now, ma'am.
Oh, sorry. K is 12. Okay.
Yes, ma'am.
So if k is 12, that means the required probability, which is
7 by
k,
12.
is 7 by 12. That's it. Okay. So this kind of question, if they are in exam, will save your time, right? Okay. So let's have a next question. Yeah, you can unmute yourself. Hello. If there is any doubt, please unmute and speak. Okay. So the 5, 6, and 7 has the same context. Question is, the standard method of screening for a disease fails to detect the presence of disease in 15% of the patients. To determine if new method of the screening is superior, suppose that 75 people with the disease are chosen at random and screened using the new method. The new method failed to detect the presence of disease in 6 of the patients. Okay, this is context where like probability of detecting some presence of disease is being checked by two methods. And the first question says that identify null and alternative hypothesis. So just tell me which parameter we are going to check here, and against what we will be testing. They says some standard method of screening for a disease will fail to detect presence of disease in 15% of the patient. Okay. And the new method, for new method, they haven't given any percentage. They said some 75 people with disease are screened using new method, and out of them, 6 diseased patients were not detected. So what is our point of concern in this particular part? What will be testing?
Ma'am, this is the probability that how much machine is failing.
Yeah, okay. So what should be our hypothesis there? That is the question, right?
The presence of percentage of the presence of disease, ma'am. That is P equal to 0.15.
Okay.
So we want to improve the test. Means less the new machine should give more precise. That is less than 15%.
Okay. So you are saying take less than 6, right? Sorry, less than 0.15.
Yes.
Why not greater than 0.15?
So
Because it may be possible that in new screening method, the what we say detecting is much more poor than the standard method. So how will you check whether to use a new method or standard method?
Ma'am, it is saying that the new machine should be superior than the existing machine, ma'am. Existing machine is having the failure of 15%. So the new machine should be less than 15%, ma'am. because they are assuming that the new machine is superior.
Yeah, fine. Yes, correct. And one more hint you can take is, yeah.
Ma'am, in that case, it should be greater than 15%. It's
No,
superior.
it's superior. That means it will detect more, right? And this probability, which is 15%, that means if I write in 0.5 or 15%, both are same, right? The probability of failing to detect this P is probability of failing the disease, failing to detect the disease. So if your new machine is superior, what should be the probability? It should be higher or lower than the previous?
It should be lower.
This is probability of failing to detect, right?
Yeah.
Yeah, got it, ma'am. Got it.
Detect disease. Fine. Then, so yeah, then in that case, you will use a probability less than what is it, 0.15. Fine. And one more hint that I was telling is they have taken sample of 75 patients, and they found that in when they take 75 patients, the how many number, like 6 patients, in 6 patients the new method was failed to detect, right? Failed to detect disease.
That is
So can you
8%.
find the probability here?
Yeah, that is
That is
8%.
8%.
That is
8%.
it 8%? How did you calculate it?
6 by 75.
6 and 75, then 1800.
Okay. The probability okay, of failing, can we just calculate it by 75, sorry, 6 by 75?
Then it is 1800.
Yeah, that's what, 8%, right? 6 by 75. That will be the probability, right? If you took
Yes.
your n
Yes,
as 75 and out of 75 you got 6, which is failed to detect the disease, how to calculate the probability? That is 6 by 75, right? 0.08 you will get.
yes, ma'am.
Okay, fine. So just tell me which kind of taste will, okay, that was the first question, right? What will be our null and what will be our alternative hypothesis? So our null hypothesis says the probability P for the probability is 0.15, and alternative says it's less than 0.15. Okay.
And can you please explain how alternative is less than?
Yeah. So in the question they have given that first standard method, just a minute. Standard method has probability of failing to detect the disease is 0.15, okay, and we are checking for the new machine that whether it will give you uh, lesser probability or higher one. So they given that they said that the new machine, the new method should be superior to the old one. So old one has probability of what we say, failing to detect the presence of disease is 15%. Now, to determine whether your new method is superior or not, they have conducted a test. So I will not say from that line I have taken probability less than 0.15. I will say, or you can take for that they have conducted they have taken some sample of 75 deceased people and got to know that out of that, when 75 people were screened using new method, out of them 6 deceased people were machine has not detected them as a deceased people. So I just calculated the percentage of failing to detect, and that I got as a 8%. So that is actually less than 15%. And also, you can check from this line if they are checking for whether the new method is superior or not. In that case, your probability has to be less than the original one, right?
Yes, ma'am.
So that's why we took H naught alternative as less than 0.15. Okay. So next one says find the p-value of the test. Okay, what is p-value?
Calculate using the Z test and put T is equal to C in the complex
Lowest.
That's fine.
of type 1 error.
That is the procedure. What is
Lowest.
p-value?
Lowest value. Yeah.
What
Lowest value where we
Lowest alpha.
reject null. Lowest
Yeah.
value
Yeah.
of alpha.
It is lowest significance level or lowest value of alpha, whatever you say, of alpha, where we reject null. So reject null. Now, just tell me how to go with this condition that you have this kind of scenarios, and now they are asking for the p-value. So p-value is nothing but the type 1 error in some sense. It is lowest value of alpha. And what is alpha? Probability of type 1 error, right?
Yes, ma'am.
Then what to do then? For p-value, we need the value of c also, right? That is critical value. Do we have that? So how, like, I want to know, how did you guys approach this question? Reject null when it was true. Yeah.
The critical value will not be given. Instead of critical value, we have to take that 6/75, which is a particular sample's value, which is
Okay.
0.08.
Fine. Then how to proceed with that? Even though we take C as a, like, okay, you are saying that we will reject null. That means probability of T less than C, right? Or greater
Yeah,
than
T
C.
less,
What will you
T
use?
less than C.
T less than C. Given that H naught is true, that means P is equal to 1.15, right? In this particular case.
Yes, and T will follow normal of, see, the previous one will be binomial 75 comma P. So the T will follow normal of P into 1 minus P by N. So with that, we need to calculate for 0.15, what will be the mu value and what will be the sigma value, ma'am.
Okay, fine. Good. So, she is correct. She is saying that, see, in our question, we have given that first machine, standard machine, which is failing to detect the disease, has probability 0.15. Now, we move to the new machine and we are checking whether that new machine is superior or not. For that, we will conduct some test, hypothesis test. For that, we have taken our H naught as P is equal to 0.15 and alternative as P, P less than 0.15, right? Now, we also know that when they took the random sample, and then, yeah, when they took the random sample out of 75 patients, the new machine failed to detect 6 patients, right? So in that case, our new probability was
0.08.
0.08. So is it a like, it's what new machine, okay, new method, let me just try again. With new method, out of this 75, 6 were unable to, like, fail to detect, let's say. So even though the probability may or may not be less, but we are saying that, okay, when they took the 75 patient, see, the method for failed to detect disease in the 6 people. So our critical value in that sense will be 6/75, right? because they took the sample and out of that sample 6 were like there were the may I say it as a failure of the method? 6 times machine failed or method failed, right? So 6 by 75 is my critical value when my sample size was 75. Okay. So once we calculate it, this is nothing but 0.08. Okay. So this is my C value. Now, we know that we are taking 75 patients. So that means, let's say my x1 to x75 will be there. For each, let's say x is a random variable which is detecting, which is saying whether machine has detected the disease or not detected the disease. Okay. So can I write it as a xi as will take 1 if disease is detected. Okay. Okay, because we are checking machine for that only, method for that only, and we'll take 0 if failed to detect. Disease. Yeah.
Why we are taking 6 by 75 as critical value, not 0.15?
What is 0.15? Okay. 0.15 is the probability for the standard method, right? 0.15 is not our, what we say, critical value. Critical value is what, when you take any sample, when you take actual experiment, out of them, how much you failed or how much you passed, that will give you the, what we say, critical value.
This is also the probability, huh?
Yeah.
Critical value
Yeah.
is also
Yes.
the
Yes.
okay,
Ma'am?
but
Okay.
it comes from the sample.
Yeah.
Ma'am?
Yes. Yes.
Ma'am, it's a little bit confusing. Can you explain it again?
Yeah. Yeah. Sure. See,
Yes.
I replaced 1 and 0. Why it is so? Because we are interested in probability of failing the detection of disease, right? That's why I changed it. Okay. So let's start again it. Okay. So the question says, there was a standard method for detecting a disease. Okay. And that was giving the error of 15%. Okay. Error, by error, I mean that it is failing to detect the disease. Okay. So the error in the first method was 15%. So I am saying it P is 0.15. Now there was a new method, and we are going to check whether that method is superior to the old one or not. Okay. So if you want to check whether your new method is superior to old one, what should I take the hypothesis? So I will say if my old method has probability of error, like possibility of error is 0.15. If my new method has to be correct or superior to that, my like value of error should be less than that, right?
Yes, ma'am.
So I took probability P as less than 0.15. Now someone has conducted the experiment with the new method. Okay. They took some 75 deceased patient and checked with the new screening method. Okay. Let's say you already know that these 75 people has disease. Now let's check it using new method. Okay. So we checked using new method, uh, and we got that out of that 75 people, for the 6 cases, that new method failed to detect the disease. Okay. So if this kind of situation is there, how will you calculate what is the probability, what is the possibility of error in that case? There were 75 people, and you got, out of them, you got 6. For the 6, your machine failed. So I took 6 upon 75. Is it fine? Just tell me, is it fine till now? Like, if, for example, you have some 75 chocolates, dairy milks, and you are picking 6 dairy milk chocolates, what is the probability? Like, not 75, I should say, if there are 100 chocolates in a box, okay, and you are picking out of that 100, there were 75 Dairy Milk chocolates, 25 Kit Kats. Okay, and you picked 6 chocolate, and all these 6 are Dairy Milk. What is the probability that all 6 are Dairy Milk? Like you have picked 6 chocolates, and there were 75, and 75 plus 25, 100 chocolates, right? Or make it more simple. In a box, you have 100 chocolates. You pick 6 chocolate. What is the probability? 6 by 100? Okay.
Yes, ma'am.
Okay. So let me do not change the context. There are 75 patients. Okay. These are 75. There are some 75 people. Okay. 75 things are there. And out of this 75, when you checked with the new screening, the 6 members who are actually deceased, but this new machine, new method failed to detect their disease, and they claimed no, these are not deceased people. So what is the probability that our instrument is failing to detect the disease?
Yes,
So
ma'am.
the probability will be 6 upon, like, favorable outcome upon total possibilities, 6 upon 75. That will be my probability. Just don't let's call it C for now if you are getting confused. So that was one thing I have calculated. Now, for every person, 75 persons are there. For every patient, what will I do? I will check with the method that if the disease is detected, I am saying it's 0. If this is not detected, I will say it 1, because we are interested in probability of failing to detect the disease, right? Of the old machine or new machine. Okay. So this was the thing. And then how many tests we have conducted for the new machine? 7 tests, 75 tests, right? So n is 75. Out of this 75, okay, yeah. What is question? Is there any? So I took 75 random variables. So xi's are Bernoulli random variable, right? If they are taking 1 and 0, we will say it as a Bernoulli. If I take sum of all this Bernoulli, what will I get? Sum of n Bernoulli is what?
Binomial.
Binomial NP.
Binomial NP. What is n there?
0.08.
0.08. Okay, I will not say 0.08 because this is the only one case. Okay, this was a one random sample, so I will not say this probability as 0.08. I will say I don't know what is this. Yeah, that 0.15 was for the older method, right? Not for this one. So I will not.
With this, we cannot decide on one sample.
Yeah.
Right.
For this P only, we are detecting the, we are conducting this test. So we will keep it as a P only. Okay. So if T is following this kind of stuff, so do you know one thing about the binomial distribution? When your n approaches, if your x's are following binomial distribution, I should say T here. If T is following binomial distribution with n comma P and n approaches to infinity, then do you know anything about that? If this n increases after a certain limit, in statistic we take n is that limit as 30. If this n is more than 30, we can consider our T as
Normal.
Yeah, normal. But with normal, there comes 2 parameter. One is mean, one is variance, right? So if it is following normal, then what will be its mean? What will be its variance? So its mean will be, yeah, do you know?
NP.
And here
NP1
NP
minus P.
P. Yeah. Or Q or 1 minus P. Q is equal to 1 minus P. Okay. So this is sigma square. This is mu square. Sorry, mu. So I know that if T is if n is 75, I am going to consider it as a normal distribution. Now I have my T following normal distribution with mean 75p and variance as 75p into 1 minus p. Okay. So till now, is it fine? T is actually sum of random variables, right? But when we check for anything, we go for the mean, right? So let's say my x bar is x1 to x75 upon 75. So which distribution should it follow? If T is following this one, x bar is actually T by 75, then what should x bar should follow? Distribution of x bar?
Normal.
Okay. Will
Normal.
there be any change with the mean and variance?
Yeah, mu and sigma square by n.
P,
No, mean will
P,
be same.
Mean will be
Variance will
same.
be
1 minus
sigma
P
square.
by root of 75.
Yes, ma'am. Mean will be same, but
Mean into 1
variance will
minus
be
P.
sigma square by n.
Yeah, p into 1 minus p divided.
No, ma'am. I think mean is P and the variance is P into 1 minus P.
By
P
75.
into
ma'am.
1 minus P by 75. Okay, let's check why this mean will be
Ma'am, why
P1.
75?
Because there are 75 samples, no?
But then 75 is already there in the variance, right? So that is already divided.
Okay, this variance this 75 are you asking for?
Yes, ma'am.
Okay. So let's calculate how these mean and variances are changing. Okay.
Yes, ma'am.
So see, this x bar is normal again. So it is expected value of x bar. Let's check. Okay, that is mean, right? Expected value of x bar will be the mean. So how to calculate that? 1 by 75 expected values of x1 to x75. Do you agree that?
Yes, ma'am. It will be
Okay.
75
And what?
P by 75.
Yeah. And what will be the expectation of x size?
75 mu.
So just remember, I have told my x size are Bernoulli or binomial or normal. So just take what are the xi. Xi is a Bernoulli random variable. So what is its probability? P.
P.
Yeah.
We don't know that. So it's what?
70
75
by
times P.
75 P upon 75.
Okay. So the mean for the x bar is P, right? And let's
Yes.
take with the variance. Okay, variance of x bar will be
1 by
1
75
upon
square.
75 to the square.
Yeah, 1 upon
Into
75 square. Okay, let me just,
into 75 into P into 1 minus P.
yeah. So
Like
into,
175 will be cut out.
yeah, upon 75. So yeah, in variances, what we do, this constant comes with the square. So 1 upon 75 and variance of,
And square, na?
yeah, square. So variance of x1 plus x2 and so on.
75 into 1 P into 1 minus P.
So x75. Okay. So again, xi are the Bernoulli random variable. What are their variance? P into q, or what you say, p into 1 minus p, whatever is your like 1 minus p or p into q. So this will be 75 times, right? They are IIDs. So 75 times p into 1 minus p. So variance is what that we have. This is that one, right? That is variance of x bar, and this is mean. So this is our x bars distribution, that is normal with mean p and variance as p into 1 minus p upon 75. Now note one thing, what our hypothesis was. So our hypothesis was, we are checking for the method that probability is 0.15 or it is less than 0.15, right? That was our concern in this question. And just look there, this is nothing but the mean, this P, right? So according to that, which test would you like to use there? So
Cherry test.
yeah,
Why we are proceeding towards X bar? I'm unable to make it out.
why we are
Proceeding towards X bar.
because of that only. See, you can take it any number, that's not a big deal. We are checking for whether the hypothesis, probability of failing to detect the disease is 0.15 or not, right? For that, we started our hypothesis like this, okay? Once you decide the hypothesis, then we decide what? Our test statistics, right?
Yes, but
Just a minute, I'm
before
explaining that only.
okay.
Taste statistics. And what is our taste statistics? We will say, okay, reject your null when you get T less than C, right? What is your T? Right, you will decide this one, T less than C only. What is T there?
Sample mean.
Yeah, what?
Sample means X bar.
You are not audible actually.
Sample mean.
That new
Sample mean, right?
sample mean.
Sample mean. Okay. May I say it as a X bar? Okay. Because till now, whatever test we have studied, that will work either for, that will taste either for mean or for the variance, right? Now we will ask, here the question is about the probability and there is nothing like mean, how to check that, right? The
Yes, ma'am, that is my question.
actually question starts here. Actually question, like, see, this is actually a conceptual question. So I was like, first I was explaining all the thing, then I was about to explain why we are looking for the expert. So that's a
That
good
was only
observation that you notice that why we are going for the expert.
yes, ma'am.
Okay. So whenever we start our question, it will start like this, right? Now, once you reach to this X bar, just forget we had a discussion before something about X bar. Will you guys get the question that how to decide this X bar and how to taste with this P, because we have learned all the taste regarding the mean and variance only, and this particular is asking for the P. So that will be question, right? So for that, even though it was a probability of some, what we say, failing, probability of finding the failure of the particular test, right? So we ended up with this X bar. So now if I have to solve the question, I should know that Xi's are some IID samples which are following some normal distribution with some mean, with some variance, right? And after that, my null and alternative is there and P is X bar. So we were calculating P value, right? P value is what? Probability of rejecting null when it was true. Now, once I start my calculation, I need T less than C, given that H naught is true, that means P is equal to 0.15. Now, how will you proceed after that? Because till now, we know that here the part was about mean, right? And here there is nothing like that. And probability of X, P is nothing but X bar, right? How will you proceed with that X bar? So for that, all this thing, we have used a context of our question, which says that there was a two methods. One was standard, one was new method. For new method, they have given this type of scenes that 75 patients were randomly checked. 75 deceased people were checked with the new method, and they found that out of 75, 6 people, for the 6 people, the machine failed to detect. So doesn't it it is a critical value? Sounds like that. Even though you know that 75 people are deceased, but when checked with the new method, it came out to be that 6 people do not have disease, right? So this is how we calculate the critical value if all the scenarios you know, but still you know that your method is failed to detect the disease, right? Are you getting my point? They took the 75 patient, and out of that there were 75 patient, okay, that they have disease. But when checked with the new method, out of them 6 were claimed as, okay, no, you are fine, there is no disease to you. So this is how we are getting our critical value from this information. Okay. Yeah.
Ma'am, can't we say that these 6 people, we are rejecting null when null is actually true?
Yeah. Yes.
So
Yes.
one way, can I say this is alpha or P?
No, not alpha, not P.
Because I'm confused in that, ma'am. I'm thinking that we are rejecting null when null is actually true. So I'm confused with whether this is C or alpha or P. So how to go about that?
So this is okay. What is critical value actually? Critical value is actually whatever you decide for your t, that is x bar here, right? Sample mean. Okay. Once you take one sample, and okay, so let's say our t is sample mean here, right? What is sample mean here? For example, I'm giving you another context. Let's say there are 100 students and they have scored something, right? So you will take I'm asking you what is the average marks of them. What will you do? There was a test of 100 students. Let's say they have scored something out of 10, okay? And I'm asking you what is the average of class, average marks for the class. What will you do? Yeah, anyone can answer. Do you understand what I am asking?
Summation of all the 100
Yes, ma'am.
student divided by 100.
Okay, that will give you what?
It's the average of
Average value. Okay. So can I say that value? Okay. Again, the same context. You are the teacher, you conducted the test, and the test was for 10 marks, okay? And you got to know that some has scored high, some has scored low, okay? And all these things. Now, someone asks you, okay, what is the critical value for your test? Okay, critical value means how do you decide in that context what will be your critical value? You have conducted the test of 10 marks for 100 students. They have scored some random marks, obviously. And now you want to decide what is the critical value, critical value marks for your test. That will be any number lying between 1 to 10, right? In that sense, what is the critical value? That critical value is some value that will be like if that value is broken, that means student has scored higher, right? Are you getting? If you are conducting the test and some student has you will somehow you will calculate the critical value. I am not saying that what method you will use, but once you get the critical value, or you will, let's see, make a graph of it. Okay, so you will plot one graph, right? Let's say student 1, student 2, these are the roll numbers, okay? 100, and this will be your marks scored. Okay, 1, 2, 3, 4, 5, 6 till 10. Let's say somewhere 10 here. Okay, and you got plot like this. Okay, someone has scored like this, someone scored like this, so like this graph, this kind of graph you will get. Okay, you have plotted the marks of your students, 100 students, and now you will find, okay, some value is critical value. What value will be that? Let's say this one. So whoever has scored more than, let's say, 9 has broke your value, right? Or someone will say, okay, this is my critical value. Is it fine? What is the critical value in mathematics term? When the nature of the graph changes, right?
Ma'am.
Yeah.
But in our case, our critical value is rejecting null.
Yeah, that is
Whenever-
what our concern is. That's why we are oriented towards failing to detect. Yeah, okay. Then, okay, can you answer, like, if you are taking the test of the 100 student, they are scoring out of 10, how will you calculate the critical value? Will your average be work like your critical value in that sense? Can you
Yes, ma'am.
No.
can you decide, like, on the basis of average, will you decide that someone has scored more than average, less than average, average? Not
Yes, ma'am.
exactly critical
No.
value, but it will say, why no?
Because let's say there are some people who, I mean, some student got 9, above 9.
Mhm.
They are also beyond the means beyond our expectation. And if I am getting some peoples are up less than 1, they are also beyond the expectation. Means both are the I say it's a bell curve, right?
Yeah, correct. So critical is generally to cross that upper boundary, right? Generally, when we say that whether it crosses that boundary or not, it's you are right that it will give you the lower one also and the higher one also. It depends on what your context is, what you are looking for, right? For example, in this particular question, we are looking for the failing to detect, the negative side, right? So that's why I have kept my Bernoulli as take 0 when disease is detected, okay, because we are not interested in that whether it's how much it is detecting, but we are interested in the probability that how many times it's failing to detect the disease. Okay, so I give it the number 1. So if I take 75 samples and in that case 6 times is failed, right? So I will get the sum of this x1 to x75 as 6, right? Are you getting it?
Yes, ma'am.
So if my sum is 6, that means how to get then critical? The same thing that we score, like what we say, we found in the score terms, right? We'll find the average somehow. So what it is actually when you divide it by 75, isn't it the sample
This
average?
is some sort of average which is failing to detect.
Yeah, what? Failing to? Sorry.
Detect. Failing to detect. This is the average.
Yeah, this is a sample mean, like sample mean of failing to detect. Yeah.
Yes, got it.
Okay. So someone asked me what is the value C is, right? So it is the kind of value X bar. Is that like what C is, what the value of C is, what the critical value is. So critical value is a kind of sample mean. If your sample mean will be 0.08, okay, this is your critical value for the sample mean. Sample mean is, and your sample is calculating whether the method failed to detect the disease or it detected. Okay, so your samples are calculating the number of times your method failed to detect the disease, right? So in that case, my x bar will look like 6 by 75, and according to the test, if C is 0.08, okay, that is the critical value. If you come up with some x bar value, let's say 0.06. I have to reject or accept my null will be based on this x bar, right? 0.06. So I will reject my null, right? That's what we do now. If t is
Yes, ma'am.
less than c, then reject it. So if you want to cancel out the things, that means reject or accept the null, you have to compare the same quantities, right? So C is actually I am saying it is the highest sample mean. If you will get the lower than sample mean lower than this C, then reject your null. That means we are saying that no, the new machine is good compared to the older one. Okay. Are you getting it, or still there is any confusion, right?
Ma'am?
Yeah.
Ma'am, did you say that x bar is equal to 0.06?
No. Yes. That
Ma'am, is
we
it
have not. I am just giving a context.
example?
Yeah. Example. Yeah.
Okay. And because that was confusing, because again 6 by 75, 6 is again used.
Yes. Okay. No. That was just example to compare whether to value take this. How do we check our samples? Okay. So, okay, revisit the question again. It says that, okay, let me just. When this kind of reverse terminologies is there, the best way is to take in Bernoulli trials if possible, like because there are only two chances. Take one to the negative part. So that will after that part, your confusion will be sort out when you solve the questions. Okay. So the question is, the standard method of screening for a disease fails to detect the presence of disease in 15% of the patient. What did it say? When you screen the disease with the standard method, 15% of the time it is failing to detect. Okay. So that is what probability of error or probability of failing to the test. Okay, that is 15%. To determine if new method of screening is superior. Suppose to determine this condition, they have conducted test on the 75 people. 75 people with disease are chosen at random and screened using the new method. Okay. In that case, the new method failed to detect presence of disease in 6 of the patients. So, identify null and alternative that we got. Find the p-value of the test. Okay. And for p-value, we know that we should aware with the critical value. So what is critical value? In ideal scenario, that means you know that there are 75 deceased people, but still your method is giving you wrong information for 6 out of them. So that will be my critical value. Okay. So critical value here will be 6 upon 75. Okay. And then we'll look for this distribution that, okay, let xi be the Bernoulli random variable which is following, which will take value 1 when fail to detect, otherwise it will take 0. So I got to know that, okay, it's a Bernoulli, but I am interested in in x bar, like in what we say sample mean. Because why I am interested in sample mean? Because we know hypothesis test for sample mean till now only, right? So I will say, okay, if these are the Bernoulli, if I add them, this will be the binomial. Ultimately, I have to add for sample mean, right? So if it is a binomial random variable, we know that once your n reaches more than 30 or n approaches to infinity, it will behave like a normal distribution. So to avoid the confusion of mean and variance, that's why I have taken the sum first and then I divided it by 75 because there was some changes here in mean and variance that we explained there, right? And finally, we got to know that x bar is a normally distributed distribution. Okay. And why it was important to know that whether X bar is following normal or normal distribution or not? Can anyone answer that? Why it is important to
Because
have?
X bar is related to C, ma'am.
Yes, X bar is related to C, and we will be making this as a normal in when we solve it. Okay, just okay, but your answer is correct. X bar is related to C. Okay, so let's go with the null and hypothesis. Till this part, the life was easy, right? If you start the question and start to answer this kind of question, you will have your null hypothesis, you will have your sampling, phase statistics, all this. Once you reach here, you will be like you will have question. Okay, now what to do? Now xi's are normally distributed. It's not given here, but we know that X bar is okay. Then p value is what? Probability of rejecting null when it was true. Now, once you write it again, t less than c, given that p is 0.15. Now look at the X bar. Your p is nothing but the nu, right? Your p is mean of the X bar. Okay. So if even though you don't know, you will do one thing. Let me just change p there. It will confuse you more. Let's take it as a y, sum of all. Just to avoid confusion, I am making it y. Otherwise, this t and this y. Okay. So t is our sample mean, X bar, t less than c. Now what to do? To make this part as a normally distributed, what we do? We subtract it from the mean and divide it by variance upon square root n, right? And here it is given that p is equal to 0.15. So just go back and check what is p there. P is nothing but your mean for the X bar. And t is nothing but the X bar, right? You can take it as X bar only. If X bar is any random variable which is having mean nu and variance sigma, in that case, if you want to make X bar as a normal random variable, standardization of X bar, what will you do? Are you getting my question? If X bar is any random variable which is following normal distribution, or leave X bar, just have any random variable. Let's say a is any random variable which is normally distributed with some mean, with some variance. Okay, and I want to make it a normal distribution. What should I do? That we have studied, right? You will
Subtract mean
subtract it
and
from the mean and divide it by variance, right? Then only this will follow a Z distribution or normal distribution, right?
Yes.
So here we were checking for the X bar. T means X bar, right? T is X bar. So X bar is a normally distributed random variable with some mean, with some variance. I have to make it a standard normal distribution. So I have written in the normal form. And now just put all this value there. X bar minus, what is P there? P, sorry, nu there, P. And that is also, okay, let's make it 0.15. And what is variance there? It is, sorry, variance is P into 1 minus P.
P n minus P1 minus
1
P.
minus p.
And divided by square root of
Root
75.
75.
Okay, is less than C minus nu upon, okay, let me put it as P. Okay, and this is again square root of P into 1 minus P upon 75. Okay, now it was given that P is equal to 0.75. right? And okay, so how that null is going to use here is in terms of this p, and there is no need to put these values here because we know that this is going to follow normal distribution with mean 0 and variance 1. Do you understand that why we did all this stuff? So we were looking for x bar for this part because if we know that your x bar is following normal with some mean with some variance, if you know that, you can subtract that mean and divide it by your standard variation and will get as a z distribution. Z less than c minus p upon square root of p into 1 minus p upon square root of 75. Okay, so put all these values there, and okay, p is 0.15. Okay, so this was your p value, right? We are calculating p value here. Okay, what is the value of c? 0.08, right? We have calculated 6 upon 75, 75, and p is what? 0.15. Why I am able to put 0.15 here, even though we are checking for the p value? Yeah, what logic will you give to me there?
Existing,
Yeah, what?
because it's a existing sample.
Because we have taken h naught as true.
Yes, H naught.
Because h naught is true, that means it's saying that p is equal to 0.15. But when you use this formula, you will forget where to use this p. So I write in terms of new there, so that we can connect it with this x bar, and you can see that okay, the p is here only. But initially, if I put p here, then it will be, I think it would be more confusing. So I just put new there, and then later I put p there.
Ma'am,
Yeah.
I have one question, that whatever critical value we are calculating, that is always for the new sample, for the
Yes.
new
Yes. Yes.
samples.
New sample. New sample. Actually, it should be the ideal sample.
Okay, I do.
Ideal collection where the scenarios you know, but still you are getting some false things, right? You know what should be the result, but you after that you got to know that okay, this machine has failed to detect this part. Okay,
What?
so okay, once we calculate this part, we'll get some values z less than negative 0.1.6. Okay, haven't you guys visited this question when you were solving mock test?
Yes, ma'am.
Yeah, what?
I have
Okay, then then how did you solve it? Like, was the method similar to this or something else?
yeah, it was similar to this, but I was wrong because of I have taken greater than that
Okay,
critical
hypothesis.
value. Yeah,
Okay, okay. But did you get why we are telling it as a lesson? Because we want
yes,
the machine to be superior, right? New method to
yes.
be superior. Okay, so this is how we found out our p value is 0.04. Okay, any doubt till now? Anyone? Okay, so let's move to the next question.
Ma'am,
Yeah.
ma'am, I'm getting FZ of 1.81.
Okay, with that calculation,
FZ of minus 1.81.
wait, this one, this calculation you are getting what?
Yes, ma'am. FZ of minus 1.81.
minus 1.81. Okay. Please verify it once again if there is any mistake in there in the calculation part only.
No, ma'am. I verified it.
Okay. Let me just recheck if there was any mistake. Okay.
Ma'am, I'm getting the same
Ma'am,
answer, ma'am. FZ of minus 1.6977.
yeah, you are correct, ma'am. It's
Okay, fine. At the end, it's a calculation part, so I am leaving here. Even though it's if it is a because I have calculated, I got minus 1.69. But please calculate it again if you are getting
Yes.
change in answers. Okay. So fine. Now we have the p-value. What is next question? Will you accept or reject the null hypothesis at a significance level of 5%? Okay, this is something we have discussed in last session, right? If you have the p-value and someone is giving you, asking you about the accepting or rejecting the null at a significance level of 5%, what will you do? Will you again check it for the whole calculation?
Not required, ma'am. You compare the P and significance value. So
Yeah.
P is less than significance value, so you reject the null hypothesis.
Yeah, that implies reject null. This part we have discussed in the last session, that how we come to know that whether to accept or reject based on the p-value. Okay, so this kind of questions are there where it will save your time if you know this kind of steps. Okay. So,
Ma'am, can you repeat that part?
okay.
P value we got 0.04, it is less than alpha, therefore we will reject it.
Yeah.
And because the test was if T is less than C, that's why.
Yeah, because for the T less than C, and also one more thing. You can revisit that session also. I'm explaining here in short only. See, this is how our normal distribution looks like, right? Here somewhere there will be a C value, that means a critical value. Let's say this is your critical value, right? X bar values are there, and this is your C value, critical value. And what is P value? P value is the lowest significance level where we will reject the null for the critical point C. Okay, this is your P value, right? P value is the area of region. Now you come to know that this is 0. This is your, let me just write it here, P value. Okay, the shaded part is your P value. Fine. And that P value in this particular case is 0.04. What this 0.04 indicates? The area of this region. Whenever you fall, your X bar will fall into this region, you will reject the null with this significance level. Okay, now you come to know that you are checking for the alpha 0.05. That means, can you say where alpha will lie? Will it lie under this P value region or greater than that?
It is greater
than that, ma'am.
Okay, so somewhere here it will cover some part here also, right? So when you are in this part, like this, both the part, if you consider, that is my alpha value, right? Alpha. And if we are checking at this point for significance level at 0.05, in that case, whatever we have seen till now, we will reject the null. Okay. Whenever my P is less than alpha, I will reject my null. Yeah.
Ma'am, sorry to interrupt you, but here in this problem, we have a C value will be 0.08 and alpha is 0.05 and P is 0.04.
Okay.
So how can it will be?
Okay. You will not compare your C values with your P value and alpha value. You will compare your C value with your X bar, with your mean value, sample means. You calculate your sample mean and compare it with the C. Okay. Whenever your sample mean, which I say X bar, is less than 0.08, then only you reject your null. Otherwise, no need to reject it. Okay, there are two criteria to reject your null hypothesis. One is through the sample mean, that means through your test statistic, and one is through p value and alpha value. Okay, so in this particular case, we have rejected using p value. Okay, and if you check with the sample mean, then you will compare it with the 0.08, not with the 0.04. Okay, got it?
Ma'am,
Yeah.
means alpha is rejection area, and
Alpha is,
if it is
yeah.
rejection area,
Okay. Yes.
and if is right to that, we can easily reject that.
If it is
Right to that point, then we can safely reject that. And p value is always going to be less than or equal to alpha.
yeah. If let's say this is your alpha value and then your sample mean falls into this part somewhere here, you will reject, right? Because this is
Yes,
your,
ma'am.
for 0.05, this is your rejection area, right? So, and your C value, that means critical value is falling under your rejection area when your significance level is 0.05. That's why we will be rejecting your null. Okay.
Yes, ma'am. But I have a small doubt here, ma'am.
Yeah,
Last
please.
session also I asked that p value can always be less than or equal to alpha, no? Is it possible
P
that p
value can
value
be
is
greater than alpha also. It depends. Like for example, in this case, our p value is 0.04, right? Then the question were asked for significance level 5%. Okay. And let's say I am making a new question. I am asking whether you will accept or reject your null at a significance level of 1%. What will you say? 1%. That might be question, right? So we know that our p value is 0.4. Yeah. P value is 0.04, right? So now if you draw it again, how will it look like? Something like this. Okay, just consider it. So in this case, what is your value of alpha?
0.01.
0.01, yeah. Okay, and what is p value? 0.04.
Yes,
So let's say C is somewhere here and 0.04. This is your p value. Okay. Where should my alpha should lie then? And this area is 0.04, right?
yes, ma'am.
So if alpha is 0.01, it will be somewhere here, this red part.
Yes.
With the point.
That I am getting, ma'am. But the only confusing statement for me is
Which,
the p value is the smallest alpha.
yeah, p value is the smallest alpha. No,
If
not alpha.
alpha,
Not
if
smallest
p
alpha.
value is the smallest alpha,
Mhm.
then how can alpha be 0.01 and p value can be 0.04?
We are reading the statement partially. Partially, we say that p value is the lowest significance level or lowest value of alpha. But you
Yes,
are
ma'am.
not
That is
completing the statement. Just complete the statement. This is not the p value. P value is not only the lowest value of alpha. It is the lowest value of alpha at which level you will reject your null hypothesis.
Okay, okay.
Just complete the statement. It is the lowest value of alpha where we will reject our null for the critical point C. Okay, so if my alpha is 0.01 at this critical point, like at this point, what should I do? I should accept my null, right? Because C is, for this alpha point of view, my C is lying in the acceptance region, right?
Yes, ma'am.
So that's why we will accept it. And your doubt, this is P value is not the lowest level, lowest significance level. It is the lowest significance level where I will reject the null. Okay.
Okay, okay. Okay, got
This
it.
is like something like you may have learned in the mathematics, limit supremum, limit infimum, greatest lower bound, something like that.
Yes, ma'am. Yes, ma'am. Got it.
Yeah.
Okay. Thank you.
Okay. So fine, let's move to next question. Okay. So next one is, let x be the random discrete random variable with the following PMF, where probability is 0 to 1 obviously. Consider the estimation of P from the sample -1, 0, 1, 1, -2. Using the, okay, 8 and 9. Find the method of movement estimate of P for the given sample. Okay. Method of movement estimation. How will you go for that? Method of movement.
First we will find the value of P for adding up is equal to 1, and then we find the expectation value and equate to the movement 1 upon n
Yeah.
into summation of xi's.
Yes, exactly. So, okay. So first thing is, I will say, okay, my M1 first method is, first moment is expectation of X, right? That is what our first moment is. And what
Yes.
about expectation of X when we have a distribution? So it is nothing but
Product of
summation of
probability and its
PXI, right?
value.
So I think, do you guys have your, you have that questions, right? So I'm not repeating it here. So yeah, what are the distribution here? For -2, x is equal to -2, the probability is P by 2, right? And for -1, okay, do you have that question set or not? Just a minute.
-2p plus half, man.
Yeah. Yes, what were you saying?
The expectation of x is coming -2p plus half.
Yeah. So these are the x's, -2, -1, 0 and 1, right? And what are their probabilities? So fx I'm writing, okay. It is P by 2, P by 2, 1 minus P by 2, and again 1 minus P by 2. Okay. If we have this kind of information, we can product this and sum them all once you do all these things. Okay, will you guys be able to make this calculation? This is nothing but -1 into P by 2 and plus 0 plus 1 into 1 minus P by 2. Once you solve this completely, you will get some value like what someone has said, 1 by 2 minus 2P, right? That will
Yeah.
be your expected value of X or first moment, right? M1. But this is mean, and in method of moment, what we do is we'll calculate capital M1 or we will equate this part with the literal mean of just a minute. Okay. So we will equate it with the mean of the given information. So what is mean there? 1 by n summation xi, right? Sample mean.
Yes, ma'am. Minus
Hello, ma'am.
Yeah.
In the sample value, there are two ones. Two ones are there. So that will be also used or not?
Yes, that will be used. If
two ones are there, no?
yeah. That are the values taken by your sample. So when we take sample mean, we have to consider all the values that have been taken. So it's -2, right? Not 2.
Yeah, -2.
Okay, -2 upon 5.
Yeah.
Okay. So this is nothing but -1 by 5. Okay. So we'll just equate both of this thing and we'll get the value of P, and that is what our method of moment estimator is. It's 5.
We will get 0.35 p hat is.
Yeah. So this is again a calculation part. So I'm just writing directly MME as
Yes, ma'am.
okay, -1 by 2 and then divided by 2. So we'll get P hat using method of moments, and that will be 0.7 by 2, which is 0.35. Okay. So that's how we calculate using method of moments. Just equate your first moment with mean of the sample. Okay. The next one is for the find maximum likelihood estimate of P for the given sample. Okay. So if you can observe from the given data of data table like PDF table for the sample that this is discrete sample, right? And using maximum likelihood estimator, what we do when we have to find out the MLE estimator for any parameter, what we do, we just first form our likelihood function. What is our likelihood function? Likelihood function is nothing but the product of all the sample PDF of your samples. So how many
Yes.
samples you have?
5.
In your sample, they have given your samples has taken -1, 0, 1, 1, and 2. These are the values taken by your sample. That means you have 5 samples, right? So product of all the PDFs of your PDFs by your sample, right? So we'll just make the product. So fx of x1 and multiply it with the fx of x2 and all. Fx of x4 and x5. Fine. So what are that values are there? So for x1 I have -1, right? Fx of -1, fx of 0, fx of 1, again fx of 1 and fx of 2. Now we know what are the PDFs of these fxi's from this table, right? I will put all these values there and we'll get for -1 it is p by 2.
P by 2.
For 0,
1 minus P by 2.
okay, 1 minus p by 2. For 1,
1 minus P by 2.
okay, I'm just taking square because it's 2 times and p by 2. Okay. So in likelihood function, we let her take the log. So I'm just taking it p by 2 raised to the power of 2 and 1 minus p by 2 to the power 3. Okay. In likelihood function, by MLE, we take the log on both sides and we'll differentiate with respect to p. So just take log on both sides. We'll get 2 log of p. Fine. I'm just okay. And plus 3 log of 1 minus p minus 5 log of p. Is it fine why I took this part? So you can have this as a p square 1 minus p cube and 1 by 2 raised to the power 5. Okay. So when you take log of this part, this 5 will be -5 and 2 will be there, right? So now the next part is differentiate it with respect to P and equate it to 0. Right? Del log L on del P is equal to 0. So what will get? That implies 2 log P, that means 2 by P, right? 2 by P plus 3 upon 1 minus P into minus 1 plus 0 is equal to 0, right? This part will be 0. Okay, so it's nothing but 2 by P equal to 3 upon 1 minus P. Okay, what is the value of P then? 2 minus 2P is equal to 3.
2 by 5.
Yeah. Yeah, what?
2 by 5.
Yeah, P is equal to 2 by 5. Yes.
Ma'am, can you show the calculation once?
Yeah. This part?
Yes, ma'am.
Okay, so P is 2 by 5. That is what MLE estimator. Fine. So that was.
Ma'am, in the first step, in the expectation when we are finding, then we don't need to consider two ones. No? In the first step, when we only x into ex, only x into p of x, we don't
Yeah,
need to
that is.
consider.
That is.
No need to consider two ones.
This
Yeah.
is expected value. In expected value, we'll not consider what the mean is. We'll just sum and product. What are the possible values?
Possible. Okay.
But when you have to take the mean, you have to consider the actual value, even though it is repeated. Okay.
Yeah.
Ma'am, please show the calculation once.
Yeah, what?
Please show the calculation once.
Okay, I will share the PDF also after the session.
Ma'am, I'm not understanding how that 2 came.
Sorry, what? How?
When you were taking log. Ma'am, one step ahead.
Which one? Which part?
Ma'am, here only. Okay, you have taken 1 by 2.
This one?
Got it, ma'am, got it.
Okay. So yeah, question number 10. A company has installed two machines, A and B, to fill the oil in the bottle. Standard deviation of the amount of oil from machine A and B are given to us 0.6, 0.5. Okay. So can we write it here simultaneously? This is sigma A and sigma B, right? These are the sigma A and sigma B, right? Standard deviation of amount of oil.
Yes.
The company manager suspects that average amount filled by two machine in bottle is different. What will you say it? The difference of new A and new B, right? New A, new B. The company manager suspects average amount filled by two machines in a bottle is different. He took n samples from machine A and found the average amount to be 1.2. So you got how many samples for A and new A value. A sample of 50 bottles from the machine B results in the average amount of 1.6. New B value is also given to us. If P value of the test is 0.01, find the value of N. Okay, P value is given to us. That means probability of type 1 error is given to us 0.01. And we have to calculate what the value of N. So can you just tell me which kind of question it is? Like we have studied hypothesis. Two sample test. Okay. And in two sample test, which test will you prefer?
Z test.
Z test.
Z test. How did you decided that?
They have given a standard deviation. That is means we know that standard deviation and we are calculating
We know the
for
variance.
Is that the reason? For two sample test we are talking.
Ma'am, actually we are testing for the mean and we also know the variance for
Exactly.
such a standard deviation.
That's the correct reason. So there are n samples for A and there are 50 samples for B, right? And what more information we have is mu A or I will say the sample mean we know, right? Sample mean x bar
Yeah,
1.2
1.2. Yeah.
and sample
Y
mean
bar
for
1.6. Yeah.
and p value is also given to us as 0.01.
0.01.
Question is about what is n. So have you attended this question?
Yes, ma'am. But I didn't get the right answer.
Okay, let's discuss it. So it's about whether the manager has suspected that the difference between the new and new B is not same, right? Average oil.
Yeah.
So what should be our null hypothesis?
Mu A is equal to mu B.
Okay.
Yeah.
And alternative will be?
Mu A not equal
Not
to mu B.
equal
Equal to no new.
Okay, let's define the taste statistics. What have you decided for it?
X bar minus Y bar, ma'am. That will be the test statistics, and that will follow normal.
Yeah, T is equal to modulus, let's say x bar minus y bar,
minus
whichever
Y bar.
can be higher, right?
Yes.
And reject null when?
Modulus of T is greater than C. Mu
Okay.
equal to mu. Mu A is equal to mu B.
It's greater than C, okay?
Yeah.
Okay. So fine till now. Then
T will follow normal distribution of mu A plus mu B.
yeah, first let's go with the distribution of x bar and y bar so that there will be no mistake in the distribution of
Yeah,
T.
I think that's yeah.
Yeah. So what's x bar is following? X bar is the mean of A. 1.2, mean is 1.2 and standard deviation is 0.6. So what will be your distribution for x bar?
Mu A, 0.6 the whole square.
6 the whole square. Anything else we need?
Yeah, by n, sorry.
Please mute yourself. Okay, x bar is there. And what will be our y bar? It will be a normally distributed with mean mu b and variance is 0.5 square upon 50, right? 50 samples they have taken. Fine. So what will be the distribution for T then? X bar minus Y bar, that is our T, will be distributed normally with the difference of mu A and mu B and the sum of these two as our variance. Okay. So I'm just denoting it as a sigma T so that I should. Okay. Sigma T or sigma square T? What should I say it?
Sigma T square.
Sigma square T.
Sigma square, right? Okay. So now what? We have the distribution of T. Then let's calculate the P value. We know that P value is 0.01. So that is nothing but probability of type 1 error or reject null when it was true. Given that it is true. Okay. So it's 0.01 and rejecting, that means modulus P greater than C such that mu A is equal to mu B. Okay, once we do that, just subtract it from the mean of this T, right?
Which will be 1.6 minus 1.2, 0.4, ma'am.
Yeah, what is that? No. We'll just subtract it from the mu A minus mu B.
Sorry, mu M. Okay, next. Okay,
Just to make it Z distribution, we will subtract it from its mean and divide it from its standard deviation.
Yes.
Or I'll just, I have written it sigma t. So, right?
Yes.
Okay, this should be greater than C. Again, C minus mu A minus mu B upon sigma t. Again, we have one more liberty that they are equal. So this finally is going to be 0. This is also a 0, right? So this is nothing but probability of modulus t by sigma t is greater than C upon sigma t, right? That is nothing but now this will follow a Z distribution with mean 0 and variance 1. So we can write it as modulus Z greater than C upon sigma t. Now what is the value of C here and what is the value of sigma t here? Do we know anything?
C is 0.4, ma'am. 1.6 minus 1.2. That is A bar minus B bar.
Yeah, it is given.
Ma'am, 1
Yeah.
minus. That's all.
Yeah, what?
Ma'am, sometimes we are writing mod t and sometimes t. Will it affect?
C. That's nothing but this one. We are making it inside the modulus. Okay.
Okay.
That's why it's like that. Modulus Z 1.6 minus 1.2. That is the value of C, right? So I will just write directly. Yes.
Ma'am, will the C be inside modulus because T is also inside modulus?
C is inside modulus. How? C is what actually? Modulus x bar minus y bar, right?
Yes, yes, okay.
So yes, it is 1.2 minus 1.6. That's why it's 0.4. Okay, otherwise it was negative. Okay, 0.4 upon what is sigma t there? Okay, just write sigma t now. It was 0.6 square upon n plus 0.5 square upon 50, right? That is our sigma t. So this is 0.01 and this is, okay, unknown is there. Okay, probability modulus Z greater than something. What will it give me?
2 fz of 2 times of fz, ma'am.
2 times of negative of fz, right? 0.4 upon sigma t. I am again writing because n is unknown. So anyhow, I have to take the inverse, right? Sorry. So z is less than negative 0.4 upon sigma t. Fine. So this is nothing but 2 times fz of minus 0.4 upon sigma t. Again, we do not know something about sigma t. There is n is unknown there, so I will take 2 there and inverse there. So 0.01 by 2 will be 0.05, right?
Yes,
Ma'am,
Yeah.
C is mod of x bar minus y bar, right? So why we have taken minus 0.4?
Here, see 0.4. Okay, let me just remove this part. Sigma t. See, something like that we had, right? This
Yeah,
was 0.
but usually what we take 1 minus p of z less than c by sigmas t, right?
Okay. I am explaining here. Modulus z greater than a. Okay, that means z is lying where to where? Can you tell me the
Minus a
range
to a.
for z? Yeah.
2.
Minus a to a.
Minus a to a. Is it like this type of minus a to a?
Yes.
No. Just take your inequality.
Okay.
You are saying modulus z greater than a. Is your modulus z greater than a here?
No.
This is for modulus z less than a, right?
Yes.
But what if your modulus z is greater than a? So ideally, it should be like this.
Okay.
Isn't it? So if it is like this, and we know that Z is normally distributed like this, right? Once we say that Z is less than minus A, some minus A will be here, A will be here, right?
Yes.
And if it is a normally distributed, that means it's symmetric.
Yes.
If
Yes.
it is symmetric, then A less or equal to Z part, sorry, probability of Z greater or equal to A will be equal to probability Z less or equal to minus A, right? Please unmute
Yes.
yourself. It's giving unnecessary noise. So if they both are equal, then what will you like to choose? This part or this part? We know the CDF part, so I will choose this part, right? So whenever there is a modulus Z, probability of modulus Z greater than A, I will take it as probability Z less or equal to minus A plus probability of Z less or equal to, sorry, Z greater or equal to A, right? According to the expansion. But I know that both the areas are same because Z is following normal distribution. So I will just take twice probability Z less or equal to minus A. Okay, got it? Because they are equal. And I know the distribution for this one. Not if I use this, then I have to take 1 minus twice Fz of A. Okay. So now this this was the thing there. I have taken minus 0.4 there. See, now take the inverse on both sides. So that inverse Fz inverse at a point 0.005 is equal to negative 0.4 upon sigma t. Okay, what this value is given to us, right? This is negative 2.58 is equal to negative 0.4 upon sigma t. Now just write we know that this sigma t is equal to what? 0.4 upon 2.58. Now put the value of sigma t there. That is something 0.6 square upon n plus 0.5 square upon 50 upon and this part 0.155. Okay. Then normal calculation will give you the value of n. So I'm just okay. Just take the square on both side and rest of the part addition subtraction part is there, and finally you will get n is equal to 19. I am writing direct answer due to this time constraint. You just check it. If still you get any problem there in calculation, then we can discuss on the discourse. Okay. So basically the idea was there was a two sample. It was a two sample test where the variance and some sample means were given to us. P value was also given to us, and we were being asked what is the value of number of samples, how many number of samples for a machine A has been taken. Okay, so we take our null hypothesis to be the both the means are equal once and alternative saying that they are not equal. Then we defined our test statistic, reject null if modulus T value is greater than C. Then we know that X bar and Y bar are following normal distribution, similarly T. And then we just applied our two sample test, two sample Z test. As we are checking for the mean. If we were checking for the variance, then we might have used F test. Then normal calculation is there and will lead to the answer for n. Okay, is it clear to everyone?
Null was T greater than C because we have a modulus.
Yes,
That's why.
yes, yes, correct.
Okay.
Okay, so next part is LMM. Waiting time in minutes of customers at a restaurant is exponentially distributed with unknown mean 1 by lambda. Waiting time of the last 5 customers are given to us using the above information of question 11 12. Find the maximum likelihood estimate of lambda, right? Okay. So how to do that? Again, MLE estimator. In MLE estimator, what we do? We just have our likelihood function as the product of others, right? So what information given to us? That X is distributed exponentially with parameter lambda. Okay, how did I get to know that parameter is lambda instead of 1 by lambda?
Mean is 1 by lambda.
Yeah. So the distribution, we know that its distribution will be lambda times e to the power minus lambda x, right? For all the x greater than 0. So MLE estimator for lambda. The given sample is 15, 10,
Ma'am,
5. Yeah.
ma'am, are we going to complete this today? Ma'am, because
Yeah.
math session has started.
Yeah, what?
Ma'am, actually the math session has started, so I was asking this.
Oh, okay, okay, okay. So, okay, fine. So if there any particular question where you guys have doubt, we can discuss that question. Or it seems 20 minutes we will be complete. In 20 minutes we will complete this. And
Yeah, we will continue, ma'am.
okay, these are the samples and fine. So what will be our likelihood function? That is nothing but the product of all the distributions. 1, 2, 5 fx of xi. So these are our 5 distributions, and what should be
Lambda e to the power minus lambda x. So that is lambda to the power 5 e to the power minus lambda 50.
Yeah. So this kind of stuff will be there, lambda e to the power minus lambda x2 and till lambda times e to the power minus lambda x5. So can you just say that it's something lambda power 5 and this is exponential raised to the power minus lambda again common. This will sum up, right? This powers
Yeah.
x1, x2 till x5. Okay. Do we have this sum?
Yeah,
Yes.
50.
Yes, this sum is what? 5050. Okay. So lambda power 5 into exponential minus lambda times 50. Okay. Then the easiest task again, take log on both sides. So sorry, log of L. We'll take log and then differentiate it with respect to lambda. So 5 log of lambda minus log of E. That will be 1, right? Now differentiate it with respect to lambda and make equate it to 0. So what the value of lambda are you getting there? So that will be 5 by lambda minus 50. That is equal to 0. So lambda is equal to
5 by 50.
5 by 50, yeah. So 1 by 10, right?
Yeah.
5 by 50, 0.1, yeah. So the value of lambda is 0.1. This is MLE estimator for lambda. I hope you guys are able to solve this MLE estimator questions, right? Just make the product of district PDF of the given sample and then take the log and then differentiate it with respect to your parameter and equate it to 0. Okay, that's what the method for MLE. Or take some or do some practice regarding that. Okay, find the posterior mean of lambda using exponential 1 by 10 prior. Okay, fine. How to find out the posterior mean if prior is given to us?
Likelihood into prior. Posterior proportional to?
Likelihood into prior distribution, right?
We have calculated likelihood in previous question. We can use that.
Yeah. So likelihood distribution we know. Now for prior they have given us that it is following what exponential 1 by 10, right?
Yeah.
Exponential 1 by 10. That means the distribution for this lambda will be 1 by 10 e raised to the power minus 1 by 10. Okay, just change the notation so that minus 1 by 10
lambda.
Okay. So yeah, likelihood function is given to us. Okay, so for posterior we know that it is, or if you are not confused, that is also fine. Posterior is directly proportional to likelihood distribution times prior distribution. Okay, what is likelihood distribution by the way?
Lambda to the power 5 e to the power 50 lambda.
Yeah,
minus
the
50.
value of this L. Okay, that is our likelihood distribution. Don't confuse it with log L terms. E raised to, oh yeah, exponential of minus 50 lambda, and for this one it is 1 by 10 e raised to the power minus 1 by 10. So for this part I change that notation, even though they are same only because we are estimating for this lambda, so I cannot change the notation here. So okay, again the constant part is like it's a directly proportional thing. We can remove this constant part. Okay, is it fine if I cancel it? Like because the calculation is about proportionality, so we can have that. Okay, lambda is for 5 and here it will be minus lambda common, and this 50 plus 1 by 10, right? So that is lambda raised to the power 5. Okay, does it look something similar to something?
Yes, ma'am. It is gamma alpha beta.
Yeah.
Yeah. So what will be our alpha and beta there?
Gamma 6,
Alpha is 6.
Yeah, for alpha,
50.1.
yeah, okay. Minus of 50.1 lambda. So this posterior is following gamma distribution. So the posterior distribution is following gamma distribution, right? With alpha as 6 and beta as 50.1, right? If it is, then what will be our posterior mean?
Alpha by beta. 6 by 50.1.
Mean will be alpha by beta, yeah. So 6 upon 50.1. That will be 0.12. What's next there? Okay, let x be a random variable with PDF fx which is given to as 6x times 1 minus x. Determine CDF. Okay. Once we have PDF, how to go with the CDF?
Integrate it and get it.
Okay. What will be the integration limits?
Option C, ma'am.
Option C.
Option D. D.
Okay. Just a minute. Okay. So if we integrate it, what will be the integration limits?
Limits will be from 0 to 1.
From 0 to 1, are you sure? If you integrate your PDF from 0 to 1, what will you get? If we integrate any PDF, which is given to us 6x into 1 minus x, in the range where x is lying between 0 to 1, what will you get? If this is your supporting set, integral 0 to 1, if you integrate your PDF in the supporting set, it has to give 1, right? It will not give you the answer. So
Minus
for
infinity to infinity.
yeah, what? Minus infinity to infinity will also lead to will lead your sum to be, yeah, that is fine, but will lead to the 1 only. Why it is minus infinity to infinity will cover 0 to 1 only, right?
Yes.
If you integrate over this limit, then the sum will go to 1, and that is the value of CDF at the end point, like at the value 1 and after that. But what about the middle range? Like what will be the CDF at a point 0.5? So we integrate it from 0 to x, and x can take any value lying between 0 to 1. Okay, got it? That's how we calculate the CDF, so that your x can vary and you can have your CDF accordingly. So 0 to x, f of x is what? 6x times 1 minus x dx. So just integrate it, and okay, 6 letter, it's common, and it will be integral 0 to x minus x squared dx. Okay, are you getting it? How I took the limits?
Please explain the limit once.
See, our x is any point lying between 0 to 1. If you fix the limit here 1, then if we integrate our PDF over the whole support set, then it has to give the answer 1, right? Because that is ultimately the sum of all the probabilities. But what if someone asks you, what is the CDF at a point 1 by 2?
Okay.
Then what will you do? Integrate from 0 to 1 by 2. If someone asks, okay, what is the CDF at 3 by 4? What will you do? Probability, integration from 0 to 3 by 4, right? So that's why, to keep this x as a variable only, I am taking my upper limit as x and setting it to 0 to 1 or any value actually.
So this is for any value between 0 to 1.
Yeah, 0 to 1, because if you take the values x greater than 1,
That will be
the
1.
answer will be 1 always, right? Yeah. So just integrate it. What will you get? Okay, is it clear to you? Like why I took x only?
Yes, ma'am. Yes.
Okay. So, okay, this is our final, what we say, CDF. So just multiply it 3x square minus 2x cube upon 6. Okay, great. So minus 0, right? Because it's x and 0, the things will remain same. 6 gate cancel. So our CDF is, so this is for x lying between 0 to 1. What about CDF at a point x less than 0? Because what we have calculated, 3x, yeah. What we have calculated is a CDF at a point whenever our x is lying between 0 to 1. And what about x greater than 1? Will be
That is
1.
1.
Okay. So that's our CDF. Okay. Next one is the density function of continuous random variable x is given by this distribution. Let 10 samples taken from x find the maximum likelihood estimate of x of sigma. Okay. So how to do that? Just recently we have revised with MLE that we just take the product of distribution and then we'll take log and differentiate with respect to parameter, right? So for 14th one, the parameter is sigma, right? So I will make, first I will write my distribution, that is 1 upon 2 sigma exponential of minus modulus x upon sigma. So there is some sample is also given to us, right? Some 10 samples are given to us. So what would you like to start with? I will suggest start with the likelihood function. Just forget about your sample for time being. Okay, your sample will help us to limit this product from I is equal to 1 to how much? 10, right? 1 upon 2 sigma exponential of minus of modulus of x size, right? Upon sigma. We have given 10 samples, so I will take the product of 10 samples for their values of x size. Okay. So once we make the product of it, what will we get? Okay, this is 1 upon 2 sigma raised to the power 10. Right? And exponential, if it is exponential a into exponential raised to the power p, so it is nothing but e to the power a plus b, right? So can I write it as exponential of sum of I is equal to 1 to 10 this x size upon sigma? Is it fine if I write like that? I have just
Yes,
used the properties of powers, right? Okay. So again, 1 upon 2 raised to the power 10, because it's a constant, so I am keeping it outside. 1 upon sigma raised to the power 10. And then exponential of, let's make 1 upon sigma, and this is nothing but summation 1 to 10 modulus of xi. So do we know what is the sum of this modulus xi is for 10 times? Like modulus x1 plus modulus x2, right? So
yes, ma'am. That is
what
known.
is that sum? From the given sample, we will be able to calculate the sum, and this will come something about 30. Okay. So 1 by 2 raised to the power 10 by sigma power 10, and this will be e raised to the power minus 30 by sigma. Fine. Now, what's the next step? Take the log on both sides, right? So log of L will be, yeah, what should it be? Minus 10 log sigma. And what about this? Minus 30 by sigma log E. Again, this log E is going to be 1. Okay, fine. Now again, integrate, differentiate it with respect to sigma and integrate and equate to 0. Fine. So that will give us, okay, this will be 0, and that might be minus 10 by sigma minus 30 by sigma into minus 1 by sigma square, right? Oh, sorry. Isn't it 1 by x?
Yeah, yeah, correct.
I by mistake I wrote sigma there.
Yeah.
Okay, then just solve it. It is nothing but sigma is equal to, okay, this square will get cancelled, and this 10 is equal to 30 by sigma. Okay, done. Sigma is equal to 3. My hat MLE estimator is 3. Fine. Any confusion there? Okay, then next one. $15. Okay, 15 and 16 are connected. Suppose the number of deceased people in a week because of deadly disease in a country has the Poisson distribution. A researcher wants to estimate lambda. Okay. From the studies in other countries, prior mean should be 3 and prior standard deviation is 1. He decides to use gamma prior that matches his prior mean and standard deviation. Okay, so with the given information, we can have the values for alpha and beta, right? The number of deceased people recorded over the next 10 weeks are given there. First question is find the value of alpha and beta. Do you have any idea from the question how to get the values of alpha and beta using this much of information? How did you approach this? So,
Ma'am did not get a third and fourth statement.
third and fourth statement. Okay, let me just. Okay.
How to relate
So,
these?
okay. So number of deceased people in a week because of that. Okay. So number of deceased people is following Poisson distribution. Okay, that's the one thing. Researcher wants to, we are estimating lambda, right? From the studies in the other countries. Okay, prior mean and prior standard deviation. What will be the prior? Why we are okay. So if prior things are given there, we are definitely going with the Bayesian estimator, right? So for Bayesian estimation, we always need prior distribution. So they have given that the prior mean and not prior mean. They have given one mean that is 3 and standard deviation 1. Okay.
Yes, ma'am.
Mean
Again,
and
they are
standard
giving decided gamma prior. So how to relate these
Yeah.
two statements?
So just take this as a mean, this as a standard deviation. Okay. And researcher like he decided to take the gamma distribution. Let's say so for researcher the prior distribution of lambda is following gamma, alpha and beta, whose mean is 3, whose standard deviation is 1. Did you get it? That matches his prior mean and standard deviation. Just let me just write it. So for
means mean is alpha and standard deviation is gamma and beta.
yeah. So prior distribution is that researchers has decided to take prior distribution of lambda following gamma distribution with alpha and with beta, who matches the mean 3 and standard deviation equal to what it was given 1. Right? That means variance equal to 1. Okay. That was
Alpha.
the statement. Did
Yeah.
you get it now?
Yes.
He has
This,
taken the gamma distribution, alpha and beta, which should
yes,
match
ma'am.
this mean and this variance. So if mean is given 3, according to the gamma distribution, what's the formula for mean?
Alpha by beta equal to 3.
3.
Got
And
it, got
what
it.
about variance?
Alpha by beta square.
Is 1. Okay. So 2 equation, 2 unknown, we can solve it, right? For
Yes.
alpha and beta. So this is alpha is equal to beta square. And what about here? Alpha is equal to 3 beta. Okay. Just put 3 beta here. 3 beta is beta square. And from here beta is equal to 3. Once beta is equal to 3, our alpha is 3 into 3, 9. Okay. So that is the value for alpha and beta here. Okay.
Yes.
Fine. So what about next one? Find the posterior mean of lambda for the above. Okay. Now we have prior distribution that is going to follow that gamma distribution with alpha 9 and beta 3, right? And asking for the posterior distribution, posterior mean, sorry. So first find the posterior distribution, then find the posterior mean. So now prior distribution for lambda is gamma distribution with alpha value 9, beta value 3, right? So what will be posterior then? Posterior is directly proportional to likelihood into prior distribution. Fine. So for prior distribution, how the distribution will look like? If it is a gamma distribution, the distribution should look like lambda raised to the power alpha minus 1 times e raised to the power minus lambda beta, right?
Yeah.
And alpha beta we know, so we can put the values also. Alpha is 9, beta is 3. Okay. What about likelihood estimator, likelihood distribution? Is there any information given there? Will be a product of samples, but what the samples are following? Poisson distribution?
Yes, ma'am.
It was given, right? Xi's are following Poisson distribution with lambda. So its distribution will be something like, what should it be?
E to the power minus lambda, lambda to the power x, and x factor.
Upon x. Okay, good. So this likelihood will something like product of e to the power minus lambda, lambda power x upon xi factorial, right? Fine. So just multiply there for posterior. Posterior distribution will be directly proportional to this likelihood 1 to n e raised to the power minus lambda, lambda power xi upon xi factorials.
That are constants. We can take out no, ma'am. Xi
What?
factor.
Which one?
Xi are constants, no. So we
Yeah.
take
So just can remove it. Minus 3 lambda. Okay. So will be okay. So we will just discard this as these are the constants. So we'll merge there. So product of exponentials. So that will be what? Summation directly, right? How many times? N times, because n products are there. And what about this? Lambda raised to the power xi will be lambda power summation xi, right? Exponential quantities. Are you beating it or should I write here? And lambda power 8 here. Or instead of 8, I should write alpha minus 1. Is it fine? Alpha and beta is also fine. Alpha minus 1 and here beta. Okay. It's your choice. You can write values there or because we know the values, so I think that would be better to use values only. Let's take it 9 minus 1 and minus 3 lambda, right? Okay. So I think you guys have confusion at this part, right? Just let me just take it here. So product I is equal to 1 to n exponential raised to the minus lambda power what? Xi upon xi factorials. So this product will be like something like this one, lambda power xi, x1 upon x1 factorial, right? Multiplied by e to the power minus lambda power x2 upon x2 factorial. Similarly, I will go till n times on xn factorials. So how will it look like? So e power minus lambda, how many times? N times, right? And here lambda power x1 into lambda power x2 till lambda to the power xn upon this will be the product of actually xi factorial, I from 1 to n. So these exponentials will add these lambdas how many times? N times. Again, lambda is common base here, x1 till xn. Upon this is a constant part, so we will be leaving it, this product 1 to n xi factorial. So that is nothing but e power minus n lambda. Lambda raised to the power summation of all the xi's, I is from 1 to n, and these are the products. Okay, did you got it now? So that was the explanation for it. I just wrote here. And now, exponential part, I will write it together how it look like. So again, lambda is common there. So e to the power minus lambda common, it is n plus 3. And what about here? Lambda raised to the power summation of xi's plus alpha minus 1. Okay. So the sample is given to us, right? Can we have this summation? So look at the question. We have a sample. See, this sample is given to us 10 next 10 weeks are 3, 5, 7, 0, 1, 7, 4, 9, 6, 4. We can add it, right? So summation xi will be the sum of them, and it comes out to be 46. So summation xi is given to us. It is 46. Sorry, how alpha minus 1 comes there? It is 8, right? I have put the values there. It is 9 minus 1. So it is 8. Okay. This was the prior distribution. This was the likelihood. Okay, we will revise at the end also. Summation xi is 46 and this one is given there. Okay, so, okay, 46 plus 8 and this is exponential minus lambda n plus 3. So is it looking like something? Lambda power 54 into exponential power something times lambda. And actually this n is also given to us, right? What is n?
10.
Number of samples, that is 10. Okay. So it is 10. So we can write it as lambda to the power 55 minus 1 e to the power minus 13 lambda, right? So that means our posterior is following gamma distribution.
Yeah.
With alpha value as 55 and beta value is 13. Okay, so what will be the posterior mean then?
55 by 30.
Yeah, it will be alpha by beta, which is nothing but 55 by 13. And that is something about 4.23. So that is our posterior mean. So what we did here, it was given that xi's are the random sample. They are following Poisson distribution. And so their likelihood will be the multiplication of all these 10 random samples. Just product of all these PDFs. And also it was given to us that prior distribution is following gamma distribution with alpha value as 9 and beta as 3. So I just multiplied them, and at the end I found that it's following gamma distribution with alpha 55 and beta as 13. So that was all about the mock test, right? This was the last question, it seems. Yeah. So yes, so we discussed this mock test. I hope you we have cleared your doubts. So, all the best for your examination. Is there any doubt?
Thank you.
Yeah. Okay. Thank you.
Thank you. Thank you.
Thank you, ma'am.
Ma'am, you will be sharing the solution PDF, right?
Yes, I will be sure.
Okay, thank you, ma'am.